Hey, what's going on, everyone? Mr. C here with lesson 10.7. Going to be sticking with circles today, but going over area and then also area of a sector, which is basically just a portion of the circle. Imagine like you're cutting out like a piece of pizza or a piece of pie. That's what we mean by a sector of a circle. So let's go ahead, and I'm sure you guys are all familiar with this. Our area of a circle formula. This is one people usually have memorized. For some reason, it's quoted a lot. There's songs that incorporate this. What am I saying? Formula. Incorporate this formula. The area of a circle is equal pi times the square of the radius, or the radius squared. Okay, so this is the formula we're going to be using for the area of a circle. Now, it's very similar to what we did with arc length yesterday when it comes to finding area of a sector. All right, let me draw out, I kind of explained what I meant by area of a sector, but let me draw it out. Say you have just a certain portion that you want to find. Okay, so let's say this is x degrees, some angle measure here. We're given the radius, and we want to find this area. Okay. What is this filled in highlighted area? Okay, if we want to find that, right, we're still going to use the area formula. So area of sector. Okay, we still use the pi r squared, but just like for arc length, we're only going to take the portion of it that's highlighted, which is part of this central angle. So we're going to take that and multiply it by x, whatever that is, divided by 360 degrees. Okay, so that's what we're going to be doing for finding the area of a sector. Same formula as area of a circle. Just take that central angle divided by 360 and then multiply that by your area of the circle. And that's going to give it to you. So let's go ahead and do an example. Let's find the area. And here's our picture. We have a center point P with a sector cut out. Say the radius is 15 centimeters. Okay. We're given the arc measure here, or that central angle there, is 72 degrees. Let's go ahead and find this area here of this highlighted portion. All right. So it's really as simple as just finding the area. So the area is pi times 15 squared, because 15 is the radius, but then we're multiplying that by the central angle here, which is 72. Divide that by 360. So let's go to the calculator, multiply all that out. Hello, Wes. All right, that was 15 squared. Make sure you square the radius first. Think of PEMDAS, how exponents comes before multiplication. So make sure you square first. That's a 225. Then you can multiply by pi. Okay, so we have 706.858. We'll just say 706.9. And then what are we multiplying that by? By 72 over 360. 72 over 360. So multiply by 72, divide by 360. Okay, and that's going to give me the area of that sector there, which is 141.37. We'll round that to 141.2. Okay, so area is about 141.2 0.2. This was in centimeters. Remember, it's area, so we deal with centimeters squared. Okay, centimeters squared. So that's how we find the area of a sector. Okay, that's going to be the end of today's lesson. If you would like to continue on, go ahead and continue on with us. If not, go ahead and try today's homework before you move on any further in the video. But if you stick around, here we go. We're going to continue on. And one more thing I want to talk about for today's lesson, which is the segment area. So area of a segment of a circle. So kind of confusing because segment and sector kind of sound similar, but here's the difference between a segment and a sector. Segment is this. Okay, let's say you have a sector. Okay, but these two endpoints of this arc that make the sector, let's say if we were to draw a segment there. Okay, we draw a segment containing, do a little better than that. Okay, the segment containing those two endpoints of that arc. Okay, this. If we want to find the segment area, we're referring to just this portion here. Okay, this is segment area. Okay, just that kind of filled in portion there. So, how can I go about finding that? So here's what we want to think. All right, I'm going to erase this highlight for a second. The sector area is this whole thing. Okay, it's this triangle. Okay, it's that triangle plus that segment area I just talked about, right? Let me draw that in a different color. Plus this area here, which we just went over. That's what we're trying to find. This is the segment area. Okay. So combined, this green area and the orange is technically what I was talking about before, that sector area. Okay. So in order to find just this green portion, what we can do is take that sector area. If we remove, the triangular part, the area of that triangle, we're left with the segment. So that's how we're going to do this. Again, find the area of the full sector, subtract the area of this triangle, and that's going to give us what's left there in the green. Okay, so that's what we're going to do. So let's look at an example for finding that. Let's do this picture here. Okay, there's my segment. Let's find the highlighted area. Okay. So again, take the sector, subtract the triangle, and let's see what we get. So again, the sector area, if I have a radius of 18 and the central angle of 60, the area of the sector, that's going to be pi r squared, so pi times 18 squared, times that central angle, which again is 60 degrees, so times 60 over 360. So let's see what we get for that answer. 18 times 18, multiply that answer by pi, multiply by 60 and divide by 360. Okay, get a 169.64. We're going to say 169.6. $169.6, and that was in inches. Right, so that's the area of the sector. So we want to take that, subtract this triangle area, and that's going to be my answer. So let's find what that triangle area is. So let's think. We know formula for area of a triangle is 1/2 base times height. But remember in one of the sections, I think was that 8.5? I believe it was 8.5. We had the 1/2 BC sine A formula, that trig formula, which we can use here because I know this is 18. Even though it's not listed here, it is a radius, so it has to be congruent to this other radius. So we have a side angle side situation. So the angle of that triangle is just going to be 1/2 of 18 times 18 times the sine of 60 degrees. Okay, that's going to be my area of the triangle. If that doesn't look familiar, go back and watch. I believe it's 8.5. It's the one titled Trigonometry and Area. It's that lesson. I'm pretty sure it's 8.5. So go back and look at that one where we went over where this formula comes from. So let's go ahead and put that in the calculator. 18 times 18 divided by 2. And then we're multiplying that by the sine of 60. Right. Gives me 140.29. We'll say 140.3. Inches squared. Okay. And then lastly, we need to subtract these two. So the area of the segment is 169.6 minus 140.3. Let's find that. 169.6 minus 140.3. Let me make sure those are the correct numbers. 169.6, 140.3. Okay, looking good. Enter, and we get 29.3. 29.3 inches squared. That is going to be my answer for the segment area, which is what we were asked to find. Okay, so that is segment area. I hope that makes sense. That brings us to the end of our lesson. Go ahead and try today's homework now. Any questions, any comments you want to leave for me, please feel free. I miss you guys. Stay healthy, stay safe. I will talk to you later. Peace.